Lecture 35 for Math 096. Today we're going to be talking about Section 8.1, which is about synthetic division. Now remember our last lecture, Lecture 34, was about Section 5.6. And in Section 5.6 we talked about polynomial long division. In polynomial long division, we can divide any dividend by any divisor. Today, when we're talking about synthetic division, our divisor has to be a binomial. So it only works for a subset of the problems that we were looking at in section 5.6. So let's go ahead and check out the handout. As you look at the handout at the top, I've given you a reminder about some of the terminology. What's the dividend, what's the divisor, what's the quotient, what's the remainder, and then I've written once again how to write down your answers for this section. And then I've given you a table that describes synthetic division. Now, on this particular table, let's go ahead and do an example and talk about each one of these steps as we're doing the problem. So in example 1, you're going to see it says, use synthetic division to divide. So this is very specifically telling us what technique to use. So our problem, part A, we have 3x squared plus 10x plus 5, all divided by x plus 2. Once again, in terms of reminders, in terms of terminology, the numerator here is the dividend and the denominator is the divisor. So our dividend is 3x squared plus 10x plus 5, and our divisor is x plus 2. So as you look at step 1, it says that we need to make sure that both the dividend and the divisor are written in descending order with every power of x accounted for. So let's double check. As you look at the dividend, the highest power of x is 2. 1 power down would be x to the first. We have one of those, and that's written down next. 1 power down, we're going to have our constant term. So every power from the highest down to our constant term is being demonstrated here in the dividend, so our dividend is good. Divisor, same statement. Highest power in the divisor is 1, and then we go downhill from there, and every power of x from the highest down to the constant is actually being demonstrated here. So everything's good in terms of step 1. Step number 2 then says, okay, in this world of synthetic division, what we're going to do is focus entirely on the coefficients. We're not going to worry about all these x's and x squareds yet. We're going to focus in on just the coefficients. So remember that a coefficient is just the number part of a term. So in my dividend then, I have the coefficient 3, the coefficient positive 10, and the coefficient of positive 5. So step number 2 says, just write those numbers down. Okay, so I'm going to come down here and do that. We have a 3, a positive 10, and a positive 5. At this point, we're done with step 2. Step number 3 then says, we need to compare our divisor to a very special divisor. And the way the author describes it is, we're always going to compare our divisor to x minus a. So x minus a is special because I want to figure out who a is. So the author says, a is always going to be the number after your subtraction symbol. Well, our divisor right now does not look like x minus a. It doesn't look like a subtraction. So what I have to do then is figure out how to make this x plus 2 look like a subtraction. So if I make it look like a subtraction, who would I have to subtract from x to make it equivalent to adding? It'd have to be a negative 2. Because remember, subtracting a negative is the same as adding. So x plus 2 is the same as x minus a negative 2. And when I do this then, my a value, the number after the subtraction symbol, is going to be negative 2. So now that I know that then, I'm going to put a box next door to all of these coefficients that I just wrote down, and I'm going to put my a value into that box. And once again, my a value is negative 2. Now, when I do this problem, I don't really think about it in the same way that the author does. I don't think about this idea that a is always the number after the subtraction symbol. What I think about is that there's always a sign change when you go from your divisor to the a value in the box. So our divisor was x plus 2. And the a value that I put into my box was a negative 2. So once again, I always think about this as there's simply going to be a sign change. If it's x plus 2 here, we're going to have a negative 2 inside the box. So now that we have that then, we're ready to go ahead and move on to step 4. Now, to understand step 4, what you have to be aware of is that this synthetic division tableau that we're creating is in fact going to have 3 rows. So what we have right now is row 1. Then we're going to have row 2. And I'm going to leave row 2 blank right now and put a big horizontal bar below row 2. And then we'll have row 3 under that. So we have 2 more rows coming in here. So in step 4, they said that we should go ahead and bring the first coefficient from row 1 all the way down to row 3. So I'm going to skip row 2 and come all the way down here to row 3 and write down that number 3. So now that I have this then, we're ready to move on to step 5. Step 5 then says, take the a in the box, the negative 2, and multiply that times the 3 that's hanging out there in row 3. Well, negative 2 times 3 is negative 6. And I'm going to write that negative 6 in my next column. And I'm going to go up to row 2. So the negative 6 goes in column 2, row 2. So once again, negative 2 times 3 gave me that negative 6. Now that I have that, we're ready for step 6. Step number 6 says then we should add this column. If I add a 10 and a negative 6 together, I'm going to get a positive 4. Step number 7 then says repeat this process of multiplying and adding until you run out of columns. So, okay, I'm going to multiply the negative 2 in the box times the 4 down here in row 3. Negative 2 times 4 is going to be negative 8. And then I add that column. 5 plus a negative 8 is going to be a negative 3. So at this point then, I'm done with the synthetic division, but I'm not done with the problem. Remember that the directions on the handout said that our final answers will always be written dividend divided by divisor, that was what was given to us, is equal to the quotient plus the remainder divided by the divisor. So I'm not done with this problem until I figure out who the quotient is, write that down, figure out who the remainder is, write that down, and figure out who the divisor is, and write that down as the denominator of that fraction. So all of this information that I just wrote down tells me most of those answers. So now what we have to do is figure out how to tear that information out of that bottom row. Well, the first thing I'm going to comment about is that when I do these kinds of problems, I like to add in an extra vertical bar that the author doesn't. So I'm going to go ahead and put that in and then comment about it. I like to put a vertical bar before that last number in that bottom row. I like to do that because it separates the two worlds here. Everything before that vertical bar is going to go off and do one thing, and everything after that vertical bar is going to go off and do something completely different. And that's why I like to put that there. Once again, it's always going to be a vertical bar before the last number in that bottom row. So I said that these two parts then go off and do different things. Well, let's talk about what happens with both of those. So as you look at this 3 and this 4, those items are the coefficients of the quotient. And the number on the other side of the vertical bar, the negative 3, that's the remainder. So now that we have this then, we're almost ready to write down our answer. But our quotient is more than just the coefficients. So what we have to do is say, okay, when we started this synthetic division stuff, we tore all the variables away from the problem. We got rid of all the x's. In order to write down our quotient, we need to bring back those variables. So in order to understand where we have been, let's figure out what happened with this 3. This 3 came from an x squared term. So I'm just going to put an x squared next door to that 3 just to comment about that power. Well, anytime you do synthetic division, the power of your quotient will always be 1 less than the power of your dividend, because you're dividing by an x to the first divisor piece. So if we're going to have one less power here, thinking about this 3 down here, one less power than x squared is going to be x to the first. And then, once we realize that the power is always going to go down by 1, this is in descending order, so we would start with x to the first and then go downhill from there. So what that means then is that our quotient is a polynomial, and it has that x piece in it. So it's going to be 3x, and then we have a positive 4, and if I go downhill in terms of descending order, this 4 then would be my constant term for my quotient. So my quotient is 3x plus 4. Well, okay, let's come back up here then and write our answer. So the answer is supposed to be the quotient, 3x plus 4, plus the remainder divided by the divisor. Well, our remainder is negative 3. And we talked about this the other day, that you can put the plus sign and then the negative 3 and then divide by the divisor, but ultimately you want to simplify that. So instead of having that addition symbol, I'm going to put the subtraction symbol for my 3 on the outside, and then put the 3 there. And then I'm going to divide by my divisor. My divisor from the original problem was x plus 2. And there's my final answer. If I take 3x squared plus 10x plus 5 and divide that by x plus 2, my final answer is 3x plus 4 minus the fraction 3 divided by x plus 2. So once again, you cannot stop with the division to blow. You have to come in and figure out what's going on in terms of all your x's, bring those x's back into the problem to write down your quotient. So you have to have that 3x plus 4 and then everything else. So one more time, 3x plus 4 minus the fraction 3 divided by x plus 2. Now, this happens to be the same problem that I started lecture 34 for. So you can actually go back to lecture 34 and see that we got that same answer using polynomial long division.